Yeah, I'm gonna talk more about the system, not the project. So welcome, ladies and gentlemen. I'm Ákos Erdélyi, and I've always been fascinated by really large projects, but now that I'm working on one, it's really terrifying to make a commit, to push to the repository, because when you have a system that has millions of lines of code, and even the smallest change can break the build, it's really terrifying to make a change. But thankfully there is a test system in place, so if something's wrong, then it's going to come out sooner than later. And I'm here to shed some light on the processes that make making a change is less terrifying and more approachable. So let's start first in a small project. So in a small garage project, like a chest application, it's testing is mostly straightforward, and it's mostly manual because at this scale it's not really too costly, and it's usually done by the developer themselves because there is no separate tester role. I mean, if you need a tester for a chest application, you're doing something wrong. So it's mostly manually tested, and automatic testing is really optional because it's an investment. So if you want automated testing, you have to put in a lot of work to make your future work easier. And in this small scale, it's not really worth it. So if the developers are really enthusiastic, they can even try test-driven development, or nothing at all, because who is there to tell them otherwise? So, but they get really fast feedback, so if they're doing something wrong, it's immediately out there and they can improve upon it. But if you move to a medium project, so in medium projects you really need quality assurance. So a test plan or a test strategy is really advised, and separate tester roles are appearing in the team itself or as separate teams. And manual testing is really becoming painful. So automated testing is the optional approach, and it's really starting to paying off because regression testing is just a click of a button. You don't really need to spend time testing. So, and the CI environment can be built on top of this automated test system. So if you are pushing a commit to the repository, you can just automatically start the test suite and execute the test cases. And the test queue appears here. So if a bunch of developers push a commit to the repository at the same time, we don't want the test system to overload, so a test queue is these testing jobs are going into the test queue, and the test system is going to get an item from the test queue, make the test, and it's going to give a feedback to the developer, to the owner of the commit. And this feedback time is still acceptable. I mean, you just go out to drink a cup of tea, and when you get back, you have the feedback. So if a test case fails, you can immediately improve your commit. But if you move to large projects, having a large project means having an equally large test system. And these test systems are always evolving, never complete, and the complexity always grows. There is a lot of challenges regarding scalability. So you have thousands to millions of test cases, and all of these test cases are, we need to run them because we need quality assurances. And to run a bunch of test cases to a bunch of commits, you really need a powerful test system. A test server to run these tests. And the first problem is if you have a bunch of developers making a bunch of commits, and you want to test every single test case on every single commit, the test server will have a huge workload, and the the testing queue is going to get longer and longer, and the developer will need to wait longer and longer to get the feedback on how their commit did. So that's the first problem, that this test server could overload. And the second problem is that the feedback time is too slow. So if a developer makes a commit and the automatic testing system is starting the test cases, and the developer needs to wait a long time to get the feedback, because he only gets the feedback when every single test case is executed. So we need to improve on the server overload problem, and we need to cut down on the feedback time. One approach is dynamic test selection techniques. They have pros and cons, but that's another topic. But the direction I want to go in is multiple layers. So first, see a lifetime of commit before multiple layers. As you can see, the developer makes a commit, and when it gets pushed to the repository, the test server automatically starts the test cases. And a bunch of test cases are started, and when every test case is finished, then the developer is going to get feedback. But if we introduce layers to it, and when the developer makes a commit, and only one layer is starting, and when that layer is finished, the developer immediately gets a feedback. So if we make a group of test cases that are really risky and really dangerous and often fail, the developer can know really fast that his commit is not perfect, that he needs to improve upon it. And when the first layer is complete, he gets the feedback, then the second layer of the test cases are starting, and when they are finished, the developer gets that feedback. So you can have a lot of layers, and when every single layer is completed, the developer gets the feedback. So you don't have to wait that every single layer is complete. Yeah, and of course, in this large scale, there are multiple teams working on the same project in parallel, of course. Yeah, so this is the previous diagram, but linearly. So we got the feedback faster problem, but the workload is still the same. I mean, it's still the same test case, it's still the same size. But when the green test cases are finished and the developer gets the feedback, if even a single test case failed, then we don't really need to, run the other layers, because the developer already knows that something is wrong with his commit. So if a green layer is failed, the developer gets the feedback, and we don't need to run the yellow and the blue ones. So that's a sizable chunk of the workload. But the main thing with which we can shave off even more work is grouping. So we can group them by time or by the number of commits. So we can group commits, like gather all the commits that got submitted in the last 60 minutes and group them together and test them. Or, make a counter, and when the counter reaches 10 or 15 or whatever, we can gather them in a group and test them. So with this approach, we save a lot of processing power from the test server, and we can prevent an overload on the test server. And we can shorten the queue that the jobs spend in the queue, or even eliminate the queue entirely. So let's talk about common layers. The first layer is usually not grouped. So this layer is going to run the test cases on every single commit. So when a commit gets submitted to the repository, this layer is immediately starting, and the test cases are executed. In this layer, the most essential and most dangerous, the most risky test cases are executed, so the developer can know if something's wrong. So the test server gives really fast feedback because there is not that many test cases in this layer. And the developer, gets fast feedback, so he can respond if the test case is failed and improve their commit and submit again. The next layer, the second layer, is a grouped layer. And this can be grouped, hourly or by the number, like 10 or 15 commits are grouped together. And in this layer, there is a bunch of risky test cases that didn't make it to the first layer. So when this layer is finished, the developer gets the feedback, and if something failed, he can act upon it. But there is one problem, that the developer's response time is slow. I'm gonna get back to this. It's really important. It's really important why the response time is slow. And it's a really flexible layer because you can really control how much test cases are in this layer. And it's gonna affect the test server's feedback time. So it can be a fast layer or a slower layer. It really depends on the project itself. And the third layer, or the final layer, it's a grouped layer. And in this layer, at the end of the day, when the developers go home, we gather all the commits that were submitted that day and run a bunch of tests on them. So we can really test as much as we can, or as possible, but the important thing is that the feedback should be ready by morning. So if we start this layer at 6 or 7 o'clock, we have 13 to 14 hours until the developers come in at the morning and start working. And the feedback should be ready by then, so the developers can act upon the results of these test cases. The feedback time is really slow by the test server because we test as much as we can, but it really doesn't matter because the developers are at home, sleeping or drinking or whatever. And the response time by the developers is slow here as well. And it's really important why it's slow. And I'm gonna get back to it in a minute. So this is a much more complicated diagram, but at the end of the day, the developers push their commits to the repository, and the first layer immediately starts. This is the layer that the really risky, the really important test cases are in, that often fail. And these give really fast feedback to the developers. So if something failed, the developers, they get really fast feedback so they can improve upon their modification. But if everything goes right and everything's good, then the second layer starts, at every hour, or if we group by number of commits, we gather a bunch of commits together, in this case 2, and the second layer starts. But only if the first layer was successful. So the second layer starts, it has more test cases, it takes a longer time, but it's gonna give feedback when it finishes to the developer. And the developer will get this feedback on the same day, and if something goes wrong, he can improve upon it on the same day. But if everything goes right, these commits, every single commit, will get to the nightly build on the third layer, which will test really thoroughly, and is going to take all the commits that are made that day, group them together and run a bunch of test cases on them. And when the developers come back the following morning, they will have a bunch of test cases and a bunch of results. So if something goes wrong, they can act upon it on the next day. Right. Is this clear? All right. So Grouping has its pros and cons. I mean, we can save a lot of processing power because we don't test every single commit with every single test cases, because we gather multiple commits together, by time or by number of commits. And because of this, we can prevent test server overload. And we can eliminate the queue entirely or just lessen the time that these jobs spend in the queue. But on the other hand, the complexity is growing further. But I mean, what can we do? And there is issues with traceability. Because if a build fails in the second and the third layer, a test case fails, we don't know whose commits was at fault. We can't find it easily because we have multiple commits grouped together, and if a test case fails, we need to investigate that who was the owner of the commit that the test case failed because. So in Ericsson, we have an external team for this that checks these layers, and if they failed, they are investigating that who was the developer that made the commit that made the test case fail. So this is the price we pay for saving a lot of processing power. And this investigation time is the reason why the developer's response time is longer. This is what I was talking about in the second and the third layer. Because the developer doesn't know if the test case failed because of them or because of his colleague. Someone will be, I'm never making mistakes, it was someone else. And they won't even investigate. So this is why we need that external team. So regarding the traceability problem, it's only in the second and the third layer. And the developers can't find easily how their commits performed. Manual investigation is needed, and they can't easily find which layer is currently testing their commit. And this information should be available to them at all times, so we made a follow your commit tool. And the things we need to follow our commits is, of course, a list of our commits, and we need to tell that where these commits currently are in the CI framework. And of course, we need to tell the developer what the status is in, how their commits fared against the test cases in different layers. And as a bonus, we can show shortcuts to the test results and find the point of failure, that where did these layers failed, which test cases failed. So this is how it looks. It's just randomly generated test data. So we have a bunch of commits, of course. We have a last activity, date, subjects, and where the commit took place, project branch. And these buttons is the shortcut to the point of failure, so the developer can easily find where did the test cases go wrong. And a bunch of icons. This is really important, but green is good, yellow is not so good, and red is really not so good. The blue ones means that that layer is currently testing your commit. And this here, the half blue and the half red, is really important because it means that the test cases are running on your commit, the layer is currently testing it, but we already had at least one test case that failed. So the developer can get faster feedback because they don't have to wait for the layer to end. We can already notify the developers. So why is this good? It's really practical, comfortable, and useful. But what do we really care about? Pretty green icons. This is my commits. It's totally not photoshopped. But this is what you want your boss to see, your manager. And if you have your own list, it gives a feeling of ownership. I mean, this is my list. I want to keep it green. If something goes red here, I want to fix that. so it's going to be green. And you know, as I said, we can cut down on the developer response time and investigation time, so they don't need to investigate where did the test cases failed. So with this follow your commit tool, we can keep the benefits of the grouping technique without the disadvantages. So we had two problems. We had a test server overload problem, but that was solved by the grouping technique because we managed to cut down on the workload. And the developer response time was too slow, but the follow your commit tool fixed that. So these are really interesting things. So do we have any questions? These layers are run sequentially, so if the first layer is, you know, all is good, every test case is successful, then the second layer is going to be started after the first layer is complete and on the next hour. So the first layer needs to complete before the second layer starts. And this also complicates the time that the developer doesn't know that in which layer his commit is being tested.
Thank you.
You have just mentioned that there is an external team that monitors
Yes.
the results and has the task to find out who the source is, right?
Right.
And now you have shown your commits. So that is it optional that you as a developer you can have this view, or is it mandatory?
It's optionally, and sadly the external team is still needed because this tool only shows that that layer failed, but the developer doesn't know if it failed because of them. So the external team is still needed.
Okay, and what is the acceptance of this view? So I can imagine that someone is better or more experienced, the other one's less experienced. Are in general the employees satisfied, developers, with this transparency? Or
Yeah,
you don't have the experience yet?
Yeah, we haven't talked about that, so
Okay.
it's still under investigation.